Um, Hello, everyone. Hi. Thanks for coming to this workshop. We're going to start in a minute. So um, just a couple of things around this. So this URL, it's going to be the URL with all the information for the workshop, and it's a living workshop in the sense that it's going to change in the next few weeks or months. So I don't know if you've already seen Strawberry. Strawberry is quite, well, it's not really new anymore. It's been 4 years, but we're working a lot to make it more production ready or easier to make it production ready. So there's going to be quite a bit of changes in future in terms of less things you have to do manually to make like a GraphQL application more production ready, like more secure and faster and so on. So I definitely want you to keep this URL around. It's going to be updated in the next few months. And yeah, hopefully everyone has it. Again, this workshop is going to be quite interactive, so we're going to build things together. I'm happy to take any question. There is a microphone there, so anytime, just feel free to stop me to ask any questions and to repeat. Yeah, I'm going to explain what GraphQL is, but if you want to kick up the setup while I'm going to talk a bit, there's two options. One is using Gitpod, so you can click here. It goes to this service called Gitpod, which is like a remote VM that runs VS Code and allows you to quickly spin up like a machine with Python. Everything is installed, so you don't have to configure anything. I tested this morning. It should work, but if there's any issue, just let me know. We'll figure it out. Yeah, once you open this, it's gonna open a terminal. It's gonna install Python 3.10. It's gonna install other things. I guess one difference between this and the other option is using just virtualenv, and this one is using PDM, which is my package manager of choice, and I'm just using it because it's convenient. But I think you don't have to do anything with PDM, and if you have any question on that, I'm happy to also answer those. But yeah, basically once you click, it's going to install everything. And yeah, the other option is to just do it like standard. So you clone the repo, create virtualenv, install the requirements, and then run a couple of commands to make sure that everything works, which I'm going to do now as well. So just to double check that everything is fine. There we go. Yeah. Yeah, a couple of things more. So we're going to use Django for this, mostly because I'm very familiar with Django. I know how to use models and things like that. But again, this workshop is not really about Django. We're actually going to see things more in an agnostic way. So we're going to use Django models, but we're not going to use any automatic generation of GraphQL types from Django models at all. Because that's one way of doing things, but it's not really the way I would recommend to create GraphQL APIs. GraphQL API should be bespoke on the clients, not what you have on the database, but we'll see that in a moment. So this is installed, so if I run PyTest, it should work. There we go. So the output is verbose. At the moment, I'm printing all the SQL queries, mostly to show you some performance optimization in future. Yes? Second? Yeah. Don't know if there's a good way of putting this, but yeah, workshop.strawberry.rocks. Yeah. Cool. And yeah, so once everything is set up, you can run the tests, and then you can also import. It's written there, but I'll do it with you as well. You can import some podcasts. So we're gonna build an API that allows you to list podcasts and podcast episodes. And so to get some data, we can import them like this. So I created a small command line application that just fetches data from RSS feeds and loads them into the database. And again, this is very verbose because I am printing all the SQL code that's happening. Anyway, this is gonna take maybe a bit of time since we are all on the internet. Cool. Yeah. So I guess, again, do a bit of introduction as well, introduction about myself. So my name is Patrick. I've been working on Strawberry for about 4 years. I created it, 4 years ago. Don't remember the exact date, but it's been quite a while. And it's becoming quite popular. It's still a niche project, I guess, for especially GraphQL in Python. It's not super popular, but I think it's growing over time. And yeah, over the last 2 years, I think there's been quite a few people using it in production, and basically like the community around it grew a lot. So I decided to start doing workshop and basically help people starting with this project. I work at a company called Apollo GraphQL, and we do tooling around GraphQL. But we're not going to see any of that. This is like what I'm doing here is like my own thing. It's not sponsored by my company, unfortunately. But yeah, if you have any questions about that, we can talk about that. But yeah, this workshop is purely on GraphQL and Strawberry. Okay, so what is GraphQL? So if you're not familiar with GraphQL, GraphQL is a query language that allows you to query APIs and get data from those APIs. You're going to see an example of that. But basically, GraphQL is, like, to put it simply, it's an alternative to REST. It basically allows you to create APIs that you can use with your mobile application or website and so on. It was created by Facebook in 2012 and open source in 2015. And actually now is not tied to Facebook anymore. There's a GraphQL Foundation, which is fully open source, and so anyone can use GraphQL without having to worry about licensing and things like that, which is quite nice. And this company, this foundation, GraphQL Foundation, is also responsible for growing GraphQL and updating the spec and making more, I guess, future-proof and adding new features over time. Yeah, so in this workshop, we're going to learn how to use Strawberry to build GraphQL APIs. We're going to use Python 3.7 or later. I think at some point this workshop we're going to use mostly Python 3.10 or more, because there is quite a few typing features that make the code a bit nicer. But again, Strawberry at the moment works from 3.7 up until 3.11. So you can use anything. I use VS Code, but you can use anything as well there. And yeah, we're going to learn, well, this is actually, there's more things we're going to learn than this, so don't worry about that. Yeah, we're going to build a API for a podcast application. This is a project I was working on a while ago, then I stopped, but I think it's quite useful to learn a few things about GraphQL. So we can list podcasts, we can get a single podcast, we can list all the latest episodes for a podcast, and we can also subscribe to a single podcast. Okay. So I mentioned the setup. So this is the setup. You can follow it. Again, if you have issues, try use Gitpod. It should work. Fine. And yeah, I did run everything here. So yeah, I have all the data imported, and now I can run a server, and we're gonna see GraphQL itself. So there is this tool called Graphical, which is a graphical interface for GraphQL, hence the name. And it basically allows you to run API calls to your GraphQL APIs. So I guess the first thing to note here, there's this text here, which is basically where you can write a document to test the query. And so we do have one single query called hello at the moment. So this document is going to be sent to the server, and then the server is going to do its magic and fetch data. So if I click here, I'm going to see a response, right? And just want to show you a couple of things here of what is happening. So when I do this request, I'm actually doing a post request. This is a standard thing in GraphQL. Every request is a post request. And I think the reason why it's been always post request is because of the fact that this document can get quite long. And so you might end up having a document that doesn't fit into the URL in the network. So they use post. But you can also change it to beget. So if you need to, you can change to beget, and it makes things a bit more, they make it easier to cache. But we can go into that later, maybe. And yeah, when I send this document, I'm basically sending the query. And if I have some variables, like if I want to make a dynamic request, that's also going to be sent. And yeah, we're going to see, I guess this API at the moment doesn't have really much. It's only this field. So we're not going to see all the power feature of GraphQL, but we'll see them while we implement everything. On top of that, there is also like documentation. So this is built automatically by GraphQL. So every time you create a GraphQL API, it has a schema, and this schema has all the types that you can use and all the operations that you can do. So one thing to note here is that there is two root types. One is called query, and one is called mutation. Query is basically fetching data, so it could be equivalent to a GET request. In this case, we only have hello. And then we have mutation that's equivalent to like anything that's no GET, like post, delete, patch, put, and so on. It allows you to do anything that has side effects on your database, for example, on your server. Yeah, there's also another one, it's called subscription. We allow you to subscribe to events. We're not gonna see that today. Also, mutation has one field called hello as well, but we're gonna create one and see how everything works. Okay, just right there, you can follow the tutorial here, workshop.strawberry.rocks. And yeah, so that's basically like GraphQL in a nutshell. So you can send the query like this, and then you get data back. If you want to use a mutation, like the syntax is the same, but you change the operation type at the top. So you can do query or mutation. And if you omit it, that's going to be a query by default, just to make it a bit nicer to run queries. Cool. Let's see next. So as I mentioned, like GraphQL is similar to REST, but like the main difference that you only have one endpoint, which is usually /GraphQL, or it could be just slash if you have just an API. Oops. Yeah. So instead of using URLs, you send a document. So instead of going to /user or /hello, you go to /GraphQL and you send this document like we sent, and then the server is going to return the data based on the request that you made. Which is quite nice because you can basically customize the response based on what you need. So if you need some fields, you can fetch them. If you don't need them, you're not going to get them, which is what happens with REST, for example. Yeah, this could be useful, but I think it's worth mentioning. So when you execute a GraphQL request, there's a few steps that happens on the server, and this is all done for you by Strawberry GraphQL and GraphQL Core. So the first step is parsing. So we receive the JSON, we parse the query inside the JSON, and that already makes sure that you don't send documents that are not valid in terms of the shape. Then there's another step called validation, and this checks that you are basically requesting fields that exist, passing the right type of variables and so on. And so, for example, if you send a document, which maybe I can show you, like this. This is not going to run. It's not going to do anything on the server because it's not a valid document. And this happens even if you pass multiple fields. So this query is not going to run. This field, hello, is not even going to fetch because the query is not valid, which is nice. Then the last step is there's actually just two steps into the execution, but basically when we have this document, we parse into an AST, we go and see all the fields that we want to fetch, and then we call something called a resolver, which is a Python function that fetches data for that specific field. And then before returning everything, we also check that the return type is actually the one that we're expecting. So for example, if I go here, I can see that this is a string, and it's required. So if I'm sending none, I'm not going to receive none in my response. I'm going to receive an error because this field is mandatory, which is a nice feature of GraphQL, because every time you do a request, you know what you're getting back. And yeah, when you receive a GraphQL request, you get everything into data, which you can see here, or errors. So if there's any error, you're going to see here. Let's see. Actually, is there any question on this? Okay. So now I'm going to do a quick overview of how Strawberry works, because there's a few things that might be a bit confusing. So, yeah, maybe I'm going to do also an introduction of the folder and everything. So there's a couple of things here that you can not worry about. There's just the CLI, docs, and exercises. So the rest is almost everything Django specific. So there is a user, folder application that has all the models for the users. We're going to use that to authenticate later in the workshop. Then there is one folder called DB, which I put all the models ready to the podcast just because I was lazy and I put everything into one file. But there's only 2 models, so it's not crazy. So we're going to use these models to store data into the backend. And then inside DB, we also have a data folder, data module. This is kind of a service layer, so this is an abstraction on top of what Django provides. And I maybe go a bit more into the details, but this makes it easier to focus just on the GraphQL part and not focusing on Django. Like, for example, like there is a couple of things that are specific to Django here, which they're not strictly related to GraphQL. I also created some utilities for pagination. And we are going to work mostly into the API folder. So there's a view, which is basically the GraphQL view. I customized a bit to basically have a function to get the user in async, because there are some issues with Django with async at the moment. And we also see why we're using async in this case. It's for performance reason, but we'll see specifically why I'm doing everything async here. URLs is just /GraphQL. This is the schema. This is basically where our GraphQL API starts from. So as I mentioned, every GraphQL API has a schema. And for a schema, there is like usually a couple of root types. So in this case, there's a query and the mutation. The names, I mean, usually it's called query, but it doesn't have to be query. But basically, these 2 are the entry points of our GraphQL API. So when I'm doing a query, all the fields I'm going to fetch for the query are going to come from this query type here. And we can see this reflects to what we were doing before. So there is a field called hello, and that in this case returns hello words. I'm going to explain this syntax in a moment, but again, this is exactly the same that we are seeing here. So there's the query type, which has one field called hello of type string. And ignoring this for a second, Strawberry Rep, it's using Python type-ins. Don't know if you've seen, this is like the syntax is basically the same as data classes. So you basically use a decorator to tell Strawberry that this type is a GraphQL type, and then we go and read all the properties defined like this. So there's the name of the property and the type of the property. And this is quite useful because when you use a type checker like MyPy, which here we go. So it's going to complain, for example, that an argument is missing, but for example, if I pass a different type, it's also going to it's going to complain about the type as well, because it's expecting a string. And I think this is one of the best features of Strawberry, because it basically gives you the benefit of using types in Python, but also types in GraphQL, which then you can also reuse in your clients if you have steps to generate the types from the GraphQL query. I don't know if I'll have time to show you that, but I think that's pretty cool. So yeah, and then this other thing, this is again inspired by data classes. So this is a way to attach metadata to a field. So for example, you could give a custom name. So for example, if you want to call it from, which is not a valid Python keyword, you can do from underscore and then the name from. But the main thing here that we're doing is passing this resolver. And a resolver is basically a Python function that gets called when I request this field, this specific field. So for example, if I change this and I do hello 12, I'm going to call this and I get hello 12. So you can see GraphQL as maybe a glorified remote procedure call. So it basically allows you to run functions in your server, which, like, I don't know, once you put it this way, I think it's quite straightforward to understand what's happening. So like, you can say, I want to call the function for the field hello, and that's what happens. Yeah. Let's see if I missed something. Yeah, I guess like I mentioned, like we took inspiration from data classes, and we're actually using data classes under the hood. And data class is basically a Python built-in library that allows you to create, classes that already have all the useful methods like constructor, representation equality method, and so on, with just a couple of lines, which is quite nice. Yeah, we mentioned resolvers, and if you want to also, if you have everything running, you can try this out and change this and see what happens. You can also see if we do this, this is gonna complain, I think. And actually, no, there is a, if I do this, yeah. So if I'm returning something that's non-null for a field that should be non-nullable, that the field is gonna complain, the GraphQL is gonna complain. So that makes safe on your clients to assume that this field is always gonna be there. Yeah. Oh, and if I return like 1, so there is a coercion step in GraphQL that converts the types that are compatible to one to the other. Yeah. Cool. Do you have any questions about this? I know it was a lot in just a short amount of time, so yeah, here we go. Okay, so let's go with our first API. So this API is going to allow us to fetch a podcast by ID. And if the podcast does not exist, it returns none. So in REST, use the HTTP status code to basically tell the user what happened. So for example, if you haven't found something you can do 404, in GraphQL, everything is like 200. Maybe sometimes you can use 401 for authentication reasons, but like by default, everything is 200, even if you have errors. So if I, for example, do this, this is probably going to be for let me do this. Yeah, this is going to be 200 because yeah, the way GraphQL's model is always to return 200, which makes it a bit annoying to monitor things. That's why there's a lot of tools like the ones from Apollo for these kind of things. But basically, like instead of using ACP for the meaning, use the schema for the meaning. So for example, if you want to say, get me a podcast, to say that the podcast does not exist, you return none instead of returning like an error, for example. So just like some conventions that you can have. Okay, so this is our data model. So again, everything lives inside the models inside DB. We're not going to touch any of this. This should work. So the podcast has an ID, has a title, subtitle, hosted by, and I guess normal things you would expect from a podcast. Yeah, so to expose this into our API, we need to create a type. So by default, I guess one misconception of GraphQL is that I expose everything. But it's not the case. Like you expose what you want to expose in your API. I mean, there's tools that allow you to create a GraphQL API from a database, but I don't know. I don't think it's the best way of doing that because it's very easy to expose things that you don't want to expose, and also it ties your GraphQL API or your API in general to a database, which I don't know. I don't think it's the right way of doing an API. Okay, so. Let's keep it simple. Let's only expose 3 fields, so like ID, title, and description. So we can do this together, or I can do it for you as well. We can go to podcast types, and I just import everything here. Let me see. Okay. I think my editor is a bit messed up. Anyway. So to recap, I created a class called podcast. This is going to be used for the name of the GraphQL type. Again, this can be changed using the strawberry type, so if you want to change the name, you can do that as well. But by default, it gets the name of the class. And then there's 3 fields here. So title and description are both strings. And then ID is using a custom type called ID. This is a type in GraphQL that represents basically an ID, a unique identifier for something in your API. You could use integer or string here, but ID it's helpful to kind of tell the consumer of the API that this is a unique identifier for this type. Yeah, and then once we have this field, we can create a GraphQL query. So we go to podcast /query. We're going to go here. So now there is an empty query, and and I'm gonna just change this to use the to add the podcast field. So here we've done something a bit different than what we have done in our schema. So let me put this side by side. So in Strawberry, there's two ways of defining a resolver, mostly for like convenience reason. So the first way is to pass the resolver as a just as a parameter to the Strawberry.field function. This could be also a function like this. It doesn't have to be a lambda. Lambda is useful for testing and showing example. The other way is to using as a kind of decorator on a method. So you can see this as a class method or like static method decorator. And basically it's almost the same. There's under the hood, there's no difference between this and this. It's just a nicer way. Sometimes it makes it easier to kind of define resolver for a specific field in a class, because otherwise we will need to create the podcast like this. Let's say podcast. And then we will need to pass the resolver here. So we do everything in one step, which is quite nice. And what Strawberry is going to do is going to get the return type of the resolver and put it into the schema. We're going to see that in a moment. And it does the same for the arguments. So if I go back to my API now and I refresh, I should see the schema being updated. And so there is this new field called podcast, which accepts an ID, which is not, which cannot be null. So the exclamation mark means that you always have to pass this field or this argument in this case. And podcast in this case, there's no exclamation mark, so it means that it can be null. So if I go and try this now, if I go podcast, ID, something random, and I try to get the ID and title, this is how you can fetch nested fields. So like that. If I try to get this, I'm going to get null, which is the JavaScript equivalent of none, which is what we're expecting because basically we're returning none here. And we are allowing us to return none by using the optional class or type from the typing module. So inside this typing module, there is a lot of classes that you can use to basically say what type is something. So for example, you can have tuple, list, unions, and so on. And in modern Python, I think from Python 3.9 or 10, you can also do, well, this syntax you can do it from Python 3.10. So you can do podcast or none. It's the same, it's just a bit nicer. And this is one of the reasons why I recommend you to use the latest version of Python, because it makes typing a bit nicer, a bit cleaner. And in the past, for example, if you wanted to return a list, you needed to do this, importing a list from here. But now you can do list like it's lowercase, so you can use the built-in. Okay, so now we created a query that allows you to fetch a podcast by ID, but it doesn't really do anything. So it's a bit useless. So let's go and update this to use our Django database to fetch data. There we go. So this is, we've seen this, and now we're gonna do this. So there is this data module inside DB, which exposes a couple of functions that makes it easier to fetch data from our Django database. So I'm gonna use that. So I'm gonna import data, and then I'm gonna do podcast equals data find podcast by ID. There we go. And so this function is gonna try and fetch the podcast by ID from the Django database. And it's also async. Again, we're gonna see why that's the case in a moment. But in Strawberry, you can both use async and sync resolver. So I can change this. Well, I cannot change this one specifically, but if I wanted to make this non-sync, async, sorry, you can do that, and it works. The issue with Django at the moment is that if you're trying to run a database query inside an async context, so even if this field is sync, the GraphQL view that we're using is the async one, so Django is going to complain because it's not safe to run database calls inside async context. You have to use sync to async. But hopefully that's going to change in future. The Django is working, is adding, every new release is adding more async features, so things like this is gonna be easier. Yeah, so if we get, we're just gonna copy this to make it easier. So I'm getting a podcast from database. Then if there is a podcast, I'm gonna return a podcast from my GraphQL API. Just gonna do something quickly to hide some of these errors. Oh, okay. Cool. So there is Pylance is an alternative to MyPy. It's a bit more strict on types. So in this case, it's telling me that UID is not compatible with ID. So I could do string. Maybe that should work. And this doesn't matter too much at the moment, so we can ignore it. Okay. So as I mentioned, like we're fetching this podcast, and then we're returning a podcast. Podcast instance. So, like, one thing that I think it's a bit annoying from the way this API works, or like the way this is structure I put, is that this podcast is a podcast model. This is a podcast type. So there is two types named the same thing, which is a bit annoying and confusing sometimes. So we're gonna see like a nicer way to maybe at least prevent this or to make it generic. But as I mentioned, like, this is a trade-off of like creating graphical API from a database. So you either return everything, so you convert a Django model directly to a graphical type, or you do this kind of second step of creating an additional type and returning it out. I do prefer this way because it makes me think more about the API and the use case. And this is what I would recommend you. And the nice thing of this is that you don't have to worry too much about database, because you create this type, and then inside the resolver you can maybe fetch multiple things if you need to. So for example, if you needed some things that come from another model, you can do there as well. Cool, so this should work now. So I'm gonna save it, and I'm gonna try again. So actually with this way, it's gonna complain because this is not a valid UID. So we're gonna see an error here. So this is something that is not something you should keep available. So in Survey there is, I just want to explain this a bit better. So this message is coming straight from the exception that Django is raising. So Django is trying to convert this 123 to a UID, and so raises an exception because it's not able to do that. We should not throw errors like this with an API. So in Survey, there is an extension called mask errors. Let's see if I can, here we go. This extension that you can enable, and then this is basically gonna hide all these errors for you. So you don't have to worry about like leaking some parts of your code base because of because there were an exception. I'm not gonna enable this because it's gonna be useful for the workshop, but basically, like if you're working with a GraphQL API, hide all the errors if possible, because the default implementation in I think in almost any language of GraphQL is just to return the error message like that. So you need an extension to hide the message. You also get the you also get the exception here on the command line. Okay, let's actually go and get an ID. Let's see, I might have, yeah, I created a small util function to get the IDs, so we can use any of this. Oh, sorry. Okay, now if I try this and I run it, I should get all the information that I wanted. So this is coming from the database, and it's actual data. And again, one of the powerful things of GraphQL is that you can basically decide what to get. So if I want to only get the title, I can do that, like just like that. Yes, and if I try to maybe fetch an ID that's not valid, that does not exist but still valid, I'm gonna get this empty response. Okay, so yeah, this is what we got. Is there any question about this now? Now we're going to see pagination. So pagination is a bit tricky in GraphQL. Mostly because every time there is a new way of doing things, like we try to reinvent everything from scratch. Like, how do I do pagination in GraphQL? But at the end of the day, you're basically not limited by GraphQL. You can do anything that you want. So you can return something like this. So you can do a basic pagination, which you basically can pass a page number, and you can pass a number of items that you want to get for that specific page. So I think I did implement this. Yeah, so we can see how this works in a moment. We're also going to see why this might not be the best, and we're going to see a slightly more complicated version, but it's a bit more useful. So, but let's start with this. So we're going to create a new field called podcasts. There we go. I'm going to import lists here, as I mentioned. There you go. So here, we basically did the same thing that we've done before, but it's a couple of different. So first thing, we are using default values for the fields. So for example, here page, we always say we want to fetch the first page unless someone passes another one, and we always say we want to fetch 10 items unless otherwise. And then we use this function called paginate podcast, which basically does all the pagination for us. And that's pretty much it. Like it's, once you know how to create a resolver, it's pretty straightforward to create another one. Yeah.
Do you mind showing get the podcast CLI command again?
Yes. Yeah, this one.
You just run that from the terminal?
Yes.
Okay, thanks.
Yeah. Yeah, you. Oh, yes, sorry. Gonna make a bit. Okay. Any other question? Just feel free to stop me, because I might be going too fast. Again, there's quite a few things to do. Yeah, in this resolver, again, we pass into parameters and returning a list of podcasts. So I can go here, and I can try this again. If I refresh the schema, I should be able to see this new field here. So there is a podcast field here. You can see that the default values are also specified into the schema. So you can also see all of that. So I'm going to try that now. Podcasts, and I'm going to do, I'm just going to do podcast like this, and I'm going to get ID and title. And yeah, that works. It's basically what we would expect. I guess one thing to note is that when you're working with lists, like the syntax of GraphQL is the same. There is no, you don't have to use square brackets for saying I want to fetch all the items for that. It's exactly the same. Which sometimes it might be confusing because this would be, one item. This is multiple items. And yeah, we can also pass parameters like this. So I want to do page 1, and per page, if I do 2. And now it's only getting 2. And if I go page 2, it's going to get the other ones. And I guess maybe this is a good time to introduce also variables. So when you're working with GraphQL, passing parameters like this, it's fine if you're doing some testing, but it's not great if you're using a query inside your GraphQL app, because basically that means that if you want to go to page 2, you have to change the old query. And so the way to kind of fix this is to use variables. So for example, you can do query like this, and then I can pass podcast. So this first thing is the operation type. It's basically saying I'm going to do a query or a mutation. In this case, it's a query. The second thing here is a name for this operation. And this is actually not mandatory, so you can skip it, but it's basically useful if you want to do logging and basically kind of see a quick glance on a monitoring tool what operations someone was doing. And then you can specify all the variables here. So I want to do page of page of type number, integer, and in this case it's mandatory. So if I try to run this, it's going to complain because I haven't passed any variables, and you pass variables, in this case here. So page 1. And if I check the network response, I can see here that inside my payload, I'm doing an operation name, which is called fetch podcasts, then the query, and then the variables. So it's just a nicer way of dealing with like dynamic data and passing the multiple things. And this is actually going to be useful like in more advanced use cases. If you want to do, other than monitor, you can also say, I want to only allow some specific queries. So you can use the names and the document to do that. More than the name, you would use the document because you can basically have an allow list of queries and then say, have this query in my database or in my store, and I only want to allow this query to run. It's another way, which I don't think we might be able to see that today, but I don't know. Cool. One issue of this is at the moment, like, if I'm trying to fetch page, I don't know, -1, it's going to work. Well, it's going to return an error, but like, I mean, that's actually a good error. Actually, let me do something a bit more annoying. So if I do per page and if I do something like this, it's not going to complain because we not put any validation, and like allowing users to do something like this is not ideal, because we don't want them to fetch so much data because they can easily DDoS our server if there are multiple requests like this and so on. So one quick way of fixing this is by just doing an assert inside your code, which I'm just going to copy and paste like this. So let me just fix this. Okay. So here I'm basically checking if the page is less than 1, then I return an error. If it's per page is less than 1, I also return an error. And the same for max length. So I only want to allow maximum 50 items returned. So if I go and try this, see, per page must be less than 50. And so if I go to, I don't know, 40, that's going to work. So this is a very quick way of doing validation in GraphQL. We do also have some support for Pydantic. I don't think it's great at the moment. It's a bit annoying the way I use it. But you could also use Pydantic here. I really want to have Pydantic as first-class support at some point, but that's going to take quite a while. But yeah, basically this is something, again, if for every API that you're building, you should definitely make sure that you're not returning, more than specific amount of data. You can do this inside of here, inside the resolver. You can also do this inside the paginate function, which already was doing it. But again, just make sure that you do these kind of things so you don't allow people to return too much data, especially in GraphQL, since you could even do something like this. So you can request this field using an alias multiple times. Let me do this. And so you can see I'm basically doing this request multiple times, and this is going to do 2 SQL calls in our database, and it's not going to be great. So just putting some limit in place would be nice. And I'm working on another extension for Strawberry to prevent these kind of things from happening. So you can say I want to allow maximum 3 aliases. So, at the moment, you can still do a query that's not great like this, and doing a big document. And yeah, that's going to be annoying for your server. So this is a feature that's coming up hopefully soon. Like the gist of this is like every time you allow someone to kind of do filters on your database, just make sure that you limit them for doing too much. So like fetching too much data, or even filtering too many things that they might not be able to see, or should not see. So an additional issue of this is that at the moment, like, we just get a list of items, so we don't have a way to basically say, oh, there's another page, or this is the previous page. So a way to fix that is to basically change our schema to have more an additional nested level, so you can do items like this. And inside items, I'm returning the podcast, and then I can have something called page info. Or this could be anything, to be honest. And you can do something like as next, as prev, and so on. So this allows your client to basically understand what's in the response. So if you have more data or less data. I'm gonna close this page because I'm getting there all the time. Yeah, so again, we can do something like this, which is called paginated podcast. I mean, this one is a bit simpler, so maybe let's actually implement this. So we have this. So again, like it's pretty straightforward to create new types. So instead of returning a list of podcasts, I'm returning a kind of container, like a wrapper on top of that. And I also have an additional field called as next page. So here, instead of returning this, I do paginated podcast items equals this, and I think this is wrong. Let me just copy this to be easier. There we go. This next page is this, and now this is complaining because I haven't updated the type here, so I'm gonna do this quickly here, and now it works. And so if I go and try this query again, I'm gonna refresh here. So items works, and then I need to change this. And you can see here that now we have a nicer shape, a shape that's more usable for our clients. And again, this is something that you kind of need to think about, like how is this API going to be used? So if you know that, for example, this page, you need to always, you have to show the next item. This is a very basic example, but just try to model the query based on the usage. That's what I'm saying. Like, don't think about the data that you have. Think about how it's going to be used. So you make an API that's very easy to use and very flexible. So in this case, again, we have the as next page. We don't have a prev because we might not need it, but we can also add that one in. Let me check one more thing. Yeah, this is how we tested it. And before showing another way of doing the pagination, I just want to show one thing that I usually do for kind of getting rid of the duplicate code. So here, we are doing this code all over again, like we're doing here, and we might be doing it in other places in future. So one thing that I usually do is to create a class method on the podcast, which allows to convert this, a Django model into this type. And so this is what I usually do. So I create a class method, like this, and sorry, I'm just going to copy that. There we go. Just going to also fix the typing issue so that this is not. Right. So yeah, basically I create a helper method on the podcast type that basically knows how to convert a Django model into itself, and this is quite useful because you only have one way of converting this into Django model into this, and yeah, there's also other ways of creating like a generic converter, but I think this is like the cleanest and the one I do prefer the most. And it also helps a bit with types because, for example, if you do something like this, it's gonna tell you like, look, this member does not exist on the podcast model. And if you're not familiar with types as well, like this thing here, the reason why I'm putting quotes around it is because this type is not defined yet, and so we need to basically change it to be a forward reference, a reference to a type that's going to be evaluated later. There's also another way, which is from future import annotation, which is basically changing all the annotation to be strings for us under the auth. So you could do this as well, but again, it's not too important. This is something that might change a bit in future. Like there was a big debate on how this should work in future, because at the moment, like this, again, is making this a string, and it's making the code inside Strawberry another library, like Pydantic, a bit more complicated because you have to deal either with types or strings, and it's a bit messy, but in future, hopefully, we can remove some of that code that we have. But yeah, basically, this is a way to say, this is the type that does not yet exist, but it's going to exist. And type checkers like PyLance and MyPy, they know, or even Flake8, they know that this is a reference, so they're going to check if that type exists or not. And so now that we have this util function or method, we can change this, and we can do from DB like this, and we can do the same here. So a bit more nicer and easier to read. So just less code there. Cool. Do you have any question about this? Okay. Cool.
So how do we actually edit the next pages?
How do we get the next pages? How do we, do you want to know how we get if there's more pages or?
No, so we return the next pages.
Yeah.
So how do we go for the next page?
Yeah, that's a good question. So the question is basically how do we get the next page? So in this case, like, you know, in your front end, you can check if as next page is true, then you can increment this variable. Another option, you can also do next page, and this would be an integer. So you can use that inside your variable as well. So if you want to do less computation on the front end. Yeah, so this both ways, yeah. It's either you increment a counter if this is true, or you return the next page number as well. Again, this is like preference as well. I think as next page is quite common, and then you increment things. So the other pagination I want to show, it's a bit more involved, but I think it's important to kind of see this because this is going to come up a lot if you use GraphQL, which is the relay specification. And again, this was created by Facebook to basically solve the way they do pagination. And this works very well if you have pagination that has a lot of data. So like, for example, a feed on Facebook has a lot of data, and like using offset in most databases is quite slow because it has to scan the old table and go to that offset. And so one way of fixing this is going to be by using cursors, which we're going to use Django cursor pagination, this library that basically implements the cursors on Django. So basically, it's an additional paginator that allows you to kind of use a cursor instead of a offset to navigate to like a point in time or like a next items. I honestly forgot a bit how it works, but usually like if you're working with this, you don't have to worry too much how it works. But if I remember correctly, you basically need an ID that's stable and sequential, and or maybe a date time. Anyway, again, this is not too important for what we're seeing. I mostly wanted to show you this pagination because it's used a lot in GraphQL because it's being popularized by Facebook by this relay specification. And we're also going to see a couple of, one feature that I think it's really interesting in Strawberry, which is the generics. So we're going to see that as well. So the way the relay pagination works is that it's a bit verbose. It has a connection type, which is similar to our wrapper type that we created for paginated podcasts. So it includes these items, but every connection. So this is going to be, this podcast is a connection of podcasts. There's going to be page info, like we seen before, and then there's going to be a list of edges, and inside every edge is going to be a node. Again, this is quite verbose, but it can also be simplified. Like some people just do nodes instead of edges. I just wanted to show you how it works because it's going to be useful. I'm going to go more into details while we implement this. One thing of this, so there is let me see if I can find it. There we go. This pull request has been going on for a couple of maybe months in Strawberry to make the implementation relay a bit easier. So instead of doing these types that you have to do now manually, it's going to be handled for you. I don't have a code now. So this is one of those things I mentioned that it's going to be easier in future. So like once that's merged, I'm going to update this workshop to include that feature instead of us creating the types manually. But again, it's not that difficult anyway. I guess the most difficult part is to implement the cursor pagination. That's in this case is done by this Django package. Okay. So we're going to create three types now. We're going to create one, which is the connection that returns all this information, so page info, edges, And then we're going to create the page info type, which is all the information for the page. Then we're going to create the edge type, which is basically what contains our item. One reason why there is edges is that, like for root level things, so like things that come from the APIs, like from the root level, they're not too important. But if you are doing a pagination, for example, if you have a person and want to do a friend's pagination, instead of having, for example, if you want to show the relationship type between these two friends, instead of having inside the node, which might not make sense because it's a field that's specific to a connection, you can have it on edges. So, for example, if this was friends on a user, you would have edges and then, for example, relationship type. This is the reason why there is this additional edge field. So you can add additional fields that are specific to that connection. Don't know if that makes sense, but it's basically another place where you can put metadata to a specific connection between types. Okay, so again, I mentioned like we're using Django Cursor pagination, so that's going to do everything for us, which is quite nice. And we're going to use the generic type. So Python has support for generic types inside the standard library for types. And that allows you to basically create types that can be reused over time. We actually seen a couple of these already. So we've seen optional, we've seen list. These are generic types that basically allow you to basically, they can be reused for any kind of thing. So here I'm reusing list, here I'm reusing podcast. This is not really readable, but I'll show you an example of how it works. So we actually created already some for you. So we do have here, we have these 3 types. So let's start with page info is like a normal type. So has all the information that we mentioned, has next page, has preview, start, and end cursor. So this allows you to go back and forth into the page. There's also a helper method that allows you to convert the database page into a page info. And then there's these 2 types here, edge and connection. So the first thing that we did is to create a type var. So a type var is basically like a placeholder for type. So when you create a type like this, a class like this, I'm saying this is a generic class on node, and this becomes a placeholder inside your class. So if I go in my code and I do something like this, edge of string, the node here is going to be a string, and cursor is going to be a string as well. So if I do, for example, this, I can see here in the autocomplete, it's going to say, no, this is a string. If I change this to integer, it's going to change to integer. So this is a very nice way of defining types that can be reused into multiple contexts. Because this relay pagination is generic. You can work with any type that you might want. So you might have podcasts, you might have episodes, you might have users and things like that. And you don't have to create all the types all over again. Because this is gonna be done for you. And I'll show you what happens when you use this in Strawberry. So yeah, again, we created these 3 types, and now we can reuse them. So now we're gonna override the podcast field to use the podcast connection. The code is similar to what we had before. There's just a couple of more things for kind of conforming to the connection shape. So I need to import this here from api.pagination.types. I'm going to import everything. Here we go. So this is what we had before. So we're fetching. I'm going to remove this check for now. So we're using our database utils to find the podcast from after this cursor, and then we can also have a first. So I want to fetch first 10, first 20, and so on. Then I'm converting the page info from the one from the database to the one for the graphical API. And then finally, we're creating this connection. And again, this is where things can be more verbose. And this is something that pull request I show you is going to make easier. So this would be 1 line. So you can just return the list of podcasts. Basically that's it. Like this is going to create 3 more types for you automatically from the generic types. So if I go here and I change this query to be the one that we just created, so it's going to remove this for now. So I'm going to fetch the first 10 podcasts, and now you're going to see how verbose it is. So there is the page info, has next page, as prev. It's going to do first one, and you can see now there is edges. Inside edges there is node, and then there is the information that we're looking for. Again, this is a bit verbose. Like it could be changed to be nodes. Oh, sorry, nodes like this. I just wanted to show you the full API that's from the specification in Relay. There we go. So if I try to fetch this, I can see now that there is a, there's the page info, which has all the information that we wanted, and also all the edges. And I can also get the start end cursor. So this is going to be a base64 encoded string of the type and the ID. I don't know why they chose this, but I think Relay is using this for caching on the front end. So it basically has a key value store where the ID is this one, and then the cache is the value of the node. But anyway, this is just an implementation detail. And then I can do after this cursor, and I should get another one. Talk Python to me. And if I change this again, I should get this as well. And so this is how you can also do pagination with the cursor. So you get the end cursor, which is going to be the cursor for the next page, and then you can go from there. And with the generic types, you basically created this podcast connection, podcast edge automatically without you having to write any additional code. And this is going to be useful also, like once we do, for example, pagination for episodes. We're going to create another 2 types, one for the episode edge, one for the episode connection, and so on, which is quite nice because you don't have to go and create all these types manually. So you don't have to create a new connection for a specific type. Okay. There is a useful article here. It's a bit old, but it's like the specification hasn't changed, and it explains all the information about the Relay and also the difference between the standard pagination. And for example, it shows the Google pagination here, which is a page pagination. This is like page pagination is something you cannot do with Relay because it uses cursor, so there is no way to jump to a specific page. And so that's one of the trade-off also of this pagination. It allows you to list a lot of data, like quite performantly, but you cannot jump straight to a specific page, unfortunately. Definitely recommend to read that if you're curious. Cool. I'm going to pause a bit and see if there's any question. What are the benefits of generics? So let me show you this again. So if I didn't have generic, I would need to create a class called podcast connection, which has a list of edges. Also notice that here I'm using the lowercase versions. This list of edge, or podcast edge, and then page info. So this, I would basically need to duplicate all this code for every connection that I need to make. So this would be a podcast connection. Podcast edge, and this would be podcast. This would be like this.
That's something that will be in the Strawberry library itself, right?
Yes. This is exactly what the Relay pagination, the Relay implementation is going to do for you. Let me see if there is an example of this. Actually, before going into that, is that clear? So this connection podcast so these four lines are basically done in one using this. And it's the same here, so Edge, podcast. And it's fine if you have one, but once you have more, like for example, if you want to do episode, you will need to duplicate all the code all over again. So it's quite nice, yeah. Yeah, let me see if there is an example of this. Again, this pull request is quite big, and it's quite nice. It does have quite a couple of features that I think are really useful. Oh yeah, there's a guides. Yeah, this is, I'm taking maybe a bit more time, but I cannot find it now. But yeah, basically it's gonna be something like, let me see, separate the relay of field, and then you pass this, and you will return maybe just a list of podcasts. So you could return maybe this. And that would be, and all the machinery that I've done now, it would be done by Strawberry itself. We're just taking a bit of time to make sure that we gather all the cases, because this pull request is coming from Strawberry Django, which is tied to Django, and it's basically useful. It's really useful if you want to convert something directly from a Django model to a GraphQL type, but we want to make sure that this also works in a generic way. So taking a bit of time to make sure that there's all the use cases. Like for example, if you want to do this, the first implementation didn't have a way to do conversion from one type to the other manually. So hopefully that comes soon. Cool. Again, if there is any question, just feel free to stop me. So we're gonna see now just a bit of data fetching optimization. So this is something that's going to be quite important in GraphQL. So the patterns are a bit different than what you would do with REST. I mean, you can still do some of the things you can do in REST, but there's other ways which are more, I guess, GraphQL native to do the optimization. So yeah, before, I guess, understanding how the data fetching works, like we need to do a bit of work to show an issue of fetching data in GraphQL. Because, for example, if I'm doing this query, here I am, let me do this again. I'm actually only doing one single database call, which is fine. But it doesn't show what we wanted to show. So we're going to introduce now a list of episodes. So we're going to allow us to fetch the latest episodes from a podcast. So we're going to see what's going to happen in that case. Or maybe the other way around. Let's see. Yeah. So the first thing it's going to do, we're going to create a new type called episode. And this is going to represent one single episode. And there's a couple of things that are interesting here. So and let me do that. So podcast types. From I'm gonna fix this as well. Pylance is very strict on some stuff. So the couple of things that are interesting here. So first one is we're using something called Strawberry.private. So every time you put a property on a Strawberry type on a class here, that's going to be exposed to GraphQL. But in this case, we don't want to expose this podcast ID to GraphQL because it's going to be inside the podcast type. So there is another generic type called Strawberry.private, which basically it's a wrapper on any type. So you can say, I want to put a podcast ID onto the episode class, but I don't want that to live in GraphQL. And so this is a way to do that. And yeah, I think it's also quite nice. And the reason why we create this is so that we can use the podcast ID inside the podcast field. So so basically this episode type is going to have an ID, title, notes, published at, and a podcast. And the podcast is a field that returns the podcast. So it's going to return this podcast here. And to be able to do that, instead of instantiating the episode with the podcast all the time, we only pass the podcast ID. and we only fetch the podcast when it's requested. And I'm going to show that how it works that in a second, and why it's actually useful to do that way. And also we have the same thing that we've done before, so conversion from the database model to a GraphQL type. So I did write these things here. And let's also add this query. Oops. So now if I go to podcast, query, and I'm adding a new query that fetches the latest episodes, so last 5 episodes, for example, and returns them. Perfect. So if I go back to my GraphQL API, move everything, and I fetch the schema again, latest episodes, and I'm gonna fetch the title for every episode. So I'm able to see all the latest 5 episodes. And we can also see there's only one database call, which is fetching all the episode or the latest 5 episodes. This is quite nice because it's not fetching any information about the podcast because I haven't requested it. But now if I go and try to fetch a podcast, I guess one thing we're not able to fetch a podcast ID because that's private. And the other thing, we are able to fetch all the other information straight from the podcast. So one cool thing of GraphQL is that allows you to nest fields. So you can have resolvers that are nested, and they only get called if you request them. So in this case, I'm going to request information for the podcast for every episode. And I can see here I'm doing, I'm getting all the data for these episodes and the podcasts. But at the same time, I'm also doing one call for every episode, which is not what you want, because this is like if you have a lot of episodes, this is going to do a lot of database calls, and this is known as the N+1 problem in SQL, I guess. So there is 2 ways of solving this. So one way of doing this is by introspecting the GraphQL request. So let's see. Okay, I do have an example here. So in Strawberry, you can pass an additional parameter to the resolver, which is called info. And this parameter is basically similar to the request in a Django or FastAPI and so on. It basically gives you all the information of this GraphQL query. So you can see an example of this here. So if I pass info here, I need to import. This is not important for now. Right, I need to put this before. So now when I do this request, I'm also going to print this, this object, which is here. It's a bit hard to read, but it basically has all the information about this request. So it does something that's very important, which we're going to use when we do the authentication, which is the context, which allows us to get the request. And using the request, we can also get the current user. It has, let me see what else. It has the current schema if you need to, but the most important thing for like optimization, if you want to do that, is the selected fields. I do have an example here, it's a bit easier to read. So it allows you to basically see all the fields that have been requested in this GraphQL API, in this API call. Maybe I can print them. Okay, I'm gonna try that again, and hopefully we're gonna see rocket. There we go. So, and this is not, the way I'm printing it is not super useful, but basically you can see that we're fetching title and we're fetching podcast. So in this resolver, we can see that we're fetching the title and the podcast. So this gives a lot of information to us to the optimization, because I can say, oh, I'm fetching the podcast, then I'm gonna do some additional optimization. So for example, I can fetch all the episodes with the podcast with them. So in Django, you could do select related on. If you're not using Django, you can do a join and things like that. I mean, this works. The only thing is that this is coupling, again, your GraphQL API to your database. So if you change the shape of your database, you have to go and update this kind of code that does the optimization, which is a bit annoying. There is, if you're using Django specifically, so there is Strawberry Django Plus, which is done by the community, which has a optimizer, which does all of this for you. So basically, you can add this extension, and then it's gonna do, well, it doesn't show the example. Basically, it's gonna do all this optimization for you. So it's gonna check what fields have been requested, and then it's gonna fetch those with a single database call with Django, or it's gonna optimize it. Like, yeah, here we go. For example, it's gonna do prefetch related, and in some cases select related as well, which is quite neat. But again, this only works if using Django and Django models. So it can be implemented for other databases, but it's not the best way of doing this kind of optimization in GraphQL. So we're gonna see what's actually better than this, or not better, like more GraphQL native again, and it's data loaders. So data loaders are a generic way to do optimized data fetching in GraphQL, but they can also be used without GraphQL, to be honest. Let's see. Okay. So the way this works is that you create a data loader, which is a class that knows how to fetch something from a database. And basically, this class needs to know how to fetch something from a database in a batched way. So instead of fetching one item, you fetch 2, 3 at a time. Let's actually see that in a moment. There we go. Yeah, let's do this. Okay, so the first thing you need for a data loader is to basically create a loader function that you then pass to the data loaders. So in this case, we already have a Django wrapper function that allows to fetch a list of podcasts by IDs. So it's just using ID in. So it's doing select where ID is in this list. And then what we doing here, we're just returning a list of podcasts by ID. In the same order of the ID that we're getting back from what that we requested. So for example, if I'm doing, let me do this, for example, 3, I'm gonna receive something like object 1, object 2, and so on. The order is quite important. I think we might change this API to allow you to return dictionary directly. But like, the reason why I did this is like sometimes Django, even if you're passing a list of IDs, it might return a different order, as you need to make sure that you're returning the same order. So this ID needs to match these IDs here. But yeah, basically this is a way to fetch multiple items in one go. Okay. And then we create a podcast data loader, which is this, passing the function to load a list of podcasts by IDs. And that's pretty much it. This is pretty much the API of using data loader. So you create a function that allows to fetch a batch of items, and then you create a data loader for that batch. And then the way you use it is to changing all the code in your resolver to use the podcast loader instead of what we had before. It's going to remove this. So inside our episode here, instead of doing this fetch from database directly, we use the data loader here. This might be enough. Just want to double check one thing here. Yeah. I forgot to mention we're also doing the conversion from the Django database to the GraphQL type directly here, so we don't have to do it externally. Yeah, basically this is it. Like the reason why I'm doing the import here is to prevent circular imports. There's also other ways of doing this, but this is the fastest way for this workshop. Yeah, and it's basically, by doing this, we resolve the n+1 problem. We're gonna be doing 2 queries, one to fetch the episodes and one to fetch all the podcast by ID. And that's it. So you can see here, first query, fetching all the episodes, and then I'm fetching all the podcasts with those IDs. And the way this works, and the reason why we're using async, is basically the inside data loader. The code is a bit complex, but basically there is a function that creates a batch, and then it dispatches the batch into the next event loop. So the way the Python async works, there is an event loop, and then you can say, run this code in the next event loop. And so this gives enough time to Strawberry and Python to basically say, fetch this, but do it like just later, just a bit later. So it allows you to basically get all these IDs. So these resolvers are going to be called once for every episode, and then it's going to put them into the next batch. And then when the next event loop runs, it's going to fetch all of them at once, which is a quite neat API. And it basically does, in terms of the code, it's just this in Python. So you just get this class and it does everything for you. There's also like some checks, and it allows you also to use a cache. For example, with Redis, I think. Let me. Yeah, so you can create a cache. So for example, if instead of saving this data in memory, you want to save on Redis, you can also do that. You can customize it. And it's quite a nice API, and it's quite easy to use. And it also allows you to prevent from fetching too much data at once. So for example, if you, fetching 1,000 items, instead of doing one SQL call for 1,000 IDs, you can do, 10 for 100 IDs at a time. So you can also batch them. Yeah, again, this is something that's built into Strawberry. And like the theme here is like to reduce the amount of code you have to write to make all this kind of optimization. And yeah, there is also a very nice blog post about this. It goes a bit more in depth into how to explain. It also has like a nice, nice graphics. It kind of makes it more easy to understand what's actually happening here. So you can see, for example, like these are the resolvers, and they're called one at a time. And so like you can see how the optimization works. Yeah, do you have any questions about this? Could I give you a second? So this is, I haven't put anything about other kinds of optimization here, but this is optimization about how you fetch data in GraphQL. So like if you're using SQL database or an external API as well. Like one cool thing of data loader is that this works with anything. It doesn't have to be a SQL database. It could be NoSQL. It can also be a CP API, as long as it supports batching or yeah. It basically it's a very nice API that makes it generic to optimize things. Like for example, if we could change this to yeah, this function could also do HTTP calls, and I think it's quite nice that you're able to do this kind of optimization in GraphQL. And again, we might change this API to just return a dictionary, or allow you to return a dictionary instead of a list to make it a bit nicer to use. It's been requested, but I never had the time to do that. Yeah. And again, this is the reason, the only reason why we're using async is because of this. But this async is also very useful if you're doing HTTP calls, like to external APIs. Like it's quite common in GraphQL to basically create a GraphQL API that wraps REST APIs or other kind of APIs. And so async would be quite beneficial there because it allows you to run multiple requests in parallel as well, and also batch them. There is some work done for also allowing some this in a sync context, but there is an external project, but I don't know if it's stable yet. So if you want to check that, there's also a way to do it in sync. But that basically changes the execution of Strawberry. So there's more code involved, which might have some issues in future. Cool. Oh, we're doing quite well on time actually. So the next step, we're gonna see authentication. We're also gonna see mutations. So it's a way to do anything with side effects, like deleting data or even sending an email for that matter. So in terms of authentication, like again, this is nothing special or GraphQL. GraphQL uses HTTP, so you can use API keys, you can use JWT tokens or cookie-based authentication, or even basic authentication. I usually do cookie-based because I use Django and that's built into Django, so I don't have to worry too much about that. But JWT is quite common. And there's also third-party packages for Strawberry that allows you to do all the things that are necessary for JWTs, like refreshing token, getting tokens, and so on. Okay. So, yeah, mutations, I did mention this, like it's basically a way to run anything with side effect. And the main difference is that instead of doing query or not passing anything, you write mutation here, then you can run a mutation like this. Well, in this case, it returns an error because it's not implemented. But in terms of GraphQL, it's almost the same as a query, but the semantic is different. So one thing that's different is that basically like mutation means you're doing some side effects. So this is something that should not be cached or not tried more than once. And also like if you're running, if you're doing multiple field selection at the root level in a mutation. So this is something that you can do in a query. So you can fetch podcasts, and so on. This also works in mutation, but there is one key difference. So this is going to be run in parallel, like concurrently, in a query in Strawberry. So you're going to run those two resolver at the same time, more or less. In mutation, if you have multiple things, like if you have mutation 1 or 2, they're going to be sequential. That's the main difference between query and mutation in terms of the execution step. And this is done so that if there's an error here, the other mutation doesn't run. That's basically it. And if you're using get, so if you, I don't know if this actually works. Let me show an example of this. So again, I mentioned like in Strawberry and most GraphQL implementation, you can also do queries like this, like via get. You cannot do this for mutation because again, you don't want to run mutation in a get. So if I try to do this, it's going to deny, it's going to not allow it. So you cannot run mutation using get. This is also the other thing of mutation. It's just there's some safety check that doesn't allow you to do mutation using get. So that's quite nice. Okay, so we are going to do a mutation for logging in a user. Again, we're going to use most of the things that are built by Django, so our mutation is going to be pretty simple. But the way it works, it's basically the same as a query. So you create a type, and then you create resolvers for the fields in that type. So, okay, I'm just going to copy this, and I'm going to go through every single line here. So if I go to authentication, mutation, well, I did copy this a couple of times. There we go. Yeah, so we're importing Strawberry, importing this info type. So this is, again, I mentioned this earlier. This is important allows us to fetch the request from Strawberry. And then we have a class called context. Info is a generic type, and in info there is a context, which it's what holds the request. So if I go here, this is a type dictionary, which has a request and response. So I can use this to get the user, and I can also use this to change the status code, for example. And then I have a function called authenticate a login, which basically gets a request, email, and password, and then it runs the authentication on Django, and it's doing the conversion from sync to async to prevent any issue with the database. What else? Yeah, oh, then I have a type called login payload. This is basically the return type of my login mutation. And then I have this is the old mutation I have. So I have a class, which is like query, which basically holds all the fields of this mutation. There's one field called login, which has the info parameter. This is passed automatically by Strawberry, and it's what we can use to get the request from the context. And then the two parameters, email and password. And then it returns a login payload. So we try to log in. If the user is none, we return false. If it's not none, we return true. And let's actually go and try this now. Oh, yeah, one thing here, like usually you would do strawberry.field. In this case, I'm doing mutation. But if you go and see the implementation is basically the same at the moment. Like mutations are not different than field per se. Like the only difference is the way they run, but that depends on the fact that you're doing a mutation and not the way you actually implemented it. The reason why we have this as a field like this, like as a alias, is that in future we want to put like more safety guards. If you're using a DOM mutation in a query, we want to return an error because that's something that doesn't make sense. Just to make it a bit easier to prevent mistakes. Okay, so now I created this. I don't have any users, so this is gonna return false. But oh yeah, if I try to do login here, it doesn't work because I need to do a mutation. So I do a mutation, and I do email. I'm just gonna use my email. Password. And then I'm going to fetch the field, which is, there's only one field, it's called OK. Oh no, I do have a user, okay. I think I created this a while ago. Yeah, basically once I do this, I'm logged in. And I'm going to show you what's actually happening here, because like this doesn't really give you much information because it's just saying everything is fine. But when I do this, here in my response headers, there's going to be a set cookie and also set cookie for the CRF token and one for the session ID. So this is basically what it's logging me in. This is done by Django. So the function that's called authenticated login, this one is going to use this authenticate function, which is going to create the cookie for us based on the backend. But the default one is the session one, which is this cookie. And now every time I do another request, I'm going to be logged in. And if I do, for example, if I change the password and it's wrong, I'm going to receive false, and I'm not going to get that set cookie. Sorry, response headers. There's no set cookie here, so because I didn't get logged in. Does that make sense? Just maybe for reference for the future, like if you're doing JWT, like for the standard basic implementation, it would be similar to this, but you might either get a token like this here, or you can still use cookies. With JWT, you can also use cookies, which is like another way to transport them. Yeah, there's many ways of doing authentication, which is a bit annoying. So this is why I stick to cookie authentication. It's just almost everything is handled by ASFI, like Django or FastAPI libraries. Okay, so we've done this. Okay, I already created a user for you, so we already did this. So we tested everything, and we also got the cookie. So now we also want to do something with the user. So we want to check if the user is authenticated for example, preventing non-authenticated user to the mutation, or we want to allow only specific user to their mutation. For example, if we want to maybe check if they're subscribed or not, we can prevent them to do something. In this case, I'm just going to check if they're authenticated to keep it simple. So I created already his authenticated class here. So Strawberry supports permissions similar to Django REST framework. And basically, the way it works is that you can pass a permission to a field, and every time that field runs, server is going to check for the permissions. And if any of those permissions return false, then the server is going to raise an error. It's not going to run that field. So in this case, we're checking if there is a user. If the user is authenticated, then we can get the field. So let's actually go and implement this mutation here. So this mutation is going to subscribe me to a podcast. Oops. Okay, so this is similar to what we had before. We're using the info parameter to get the current user. We're getting the is authenticated permission, and then we're using that permission inside the permission classes mutation. And this is basically allowing us to make sure that this mutation only runs if there is a user logged in. In this case, we could even remove it because otherwise the user would be none. So we could do a check there, but you can see this having, I don't know, is premium user, for example, something like that. So you can make this authentication, these permissions as custom as you want. I guess one note here, we might change these permissions a bit in future to be more flexible, because for example, at the moment you cannot do or conditions inside the authentication, inside the permission. So for example, if you wanted to do something like is authenticated or is, I don't know, something, this is not possible at the moment. We want to implement that at some point in the future. And we might also get rid of the underscore classes, so we can just do this. But that hopefully is going to come sooner rather than later. But yeah, basically we check this, so we now are sure that every time this mutation runs, it's only going to run if there is a user. And then we can do all the things that we did before. So we can get the request, we can get the podcast by ID. If there is no podcast, return false. And then we get the user, and then we subscribe the user. And if there is an error, return false. Let's actually try that. Mutation, subscribe. I need to refresh this. Okay. Need to get one ID from. Okay, this one. So now this mutation is a very basic mutation, only returns true or false. It makes it a bit harder to read. So in this case, it returns false, it means I'm already subscribed or something went wrong. But if I try to run this, for example, in incognito, so if I create a new browser, if I try to run that mutation, I should get an error. So this is how you get errors using permissions, which is maybe one thing we want to make it easier to change. But basically, you get an error into the error response and saying, user is not authenticated, because again, I'm not authenticated in this case. But yeah, that's, let me see. So that's pretty much it. It's one line to make sure that you are authenticated. You have some specific permissions, which is, I think, it's quite nice. And again, this is the implementation of the permission. So you have all the information that could be useful for you to do the permissions. Like for example, there's a source, which is the root type. So for example, if this were a nested field, you could get the parent to check some more information on the parent. For example, if the parent owner is the current user, you can do something like that. You also get the context, the info, which allows you to get the current user from the context, and also additional keyword arguments for the specific field. Again, this is inspired by Django REST framework, and we might slightly change it a bit in future, but it's not going to change by much. Yeah, so again, is there any question about this? Because I wanted to show you something related to the error. So like this, this mutation is a bad mutation. This is not something you should do with GraphQL. Like returning true or false directly into mutation is not, or it's not, I don't know, it's not great developer experience or like user experience. for two reasons. Like one, this false is a bit generic. It doesn't really give you a lot of meaning on what happened. Like why did I get false, right? Because it could be for multiple reasons. Like it could be because the podcast does not exist. It could be because I'm already subscribed. And on top of that, I'm not really taking a lot of advantages from GraphQL. Like when you're doing mutations or queries in general, you should return like rich types. So in this case, we could return a podcast. So I can get also all the information back. So for example, if I'm doing a mutation that changes a podcast title, I can make it so that it returns the actual podcast with the new title, and so that I can use that title to update the UI in my application. And this is something that's actually handled automatically by clients like Apollo client or Oracle. Like if you're returning an object with a specific type and ID, it's going to update the cache and update all the pages automatically in your client, which is quite nice. But the main thing is now be able to understand what this false means. So we're going to see how to handle errors a bit better. And we've seen this. So we've seen an example of using just like standard exceptions, so raising a value error, and we get something like this in our GraphQL response, which is okay, but it's not a great experience. So like one strategy is to use something called union types. Union types are basically a way to say this field is going to return not just one type, it can return two different types, always one at a time. So we're going to see that in a second. So let's change this mutation that we had before, which is returning bool, to return different types based on either the podcast does not exist or the user is already subscribed. I guess one takeaway of this is also like there is two different types of errors in general in GraphQL. Is that expected errors, unexpected errors. Expected errors are like these ones that we just mentioned, are errors that we know that can happen, and errors that might happen a lot that you might want to show different UI to users. For example, like the podcast does not exist or the user is already subscribed. It's a good example of that. Unexpected error is anything else, like for example, database being down or I don't know, something else like not going well with this mutation. And like the idea is that you always kind of take into account all these expected errors or these errors that you want to kind of present in a nicer way to your user. And then the unexpected errors you basically do, you just leave them as it is, like you return them like this, and then there's a generic message on your UI. Yeah, so we mentioned that we're gonna handle errors using union types, and we have three cases. So podcast does not exist, user is already subscribed, or everything went well. And we're gonna model these three cases using three different types. The first one is gonna be a type called podcast does not exist error, which has just a message. And then the second one is gonna be already subscribed to podcast error. They're very verbose, but they make it very easy to understand what happened. And then the last one is subscribe to podcast success, and it returns the podcast. And then we're gonna use a union type. Let's put those here. So these three types are basically straightforward. They're just like classes that have like a field each. This type is a bit different. It uses something that's not really Pythonic and we might change in future, which is in strawberry.union to create a union from this type. This is actually equivalent of doing this, which we might actually do now because it's something I want to change in future. So basically, this is a union of these three types, and you can see here. I mean, if you want to use a variable of this type, you need to check what type it is before. And so we're gonna do that as well in GraphQL. So I'm gonna actually put this in line. Maybe it's a bit nicer, like this. So here I'm saying that this subscribe to podcast is returning one of these three types. And I mean, already getting an error from my Py, so I need to change that. But basically, when I'm using this on the client, I need to basically tell I want to fetch this field for this type and so on. So I'm going to show you that in a second. So if we don't have a podcast, we return podcast does not exist error. If it says already subscribed, we return already subscribed. Otherwise, we return the subscribe to podcast success with the podcast from database. So let's see that now. So let me do a fake podcast. So if I refresh this, the schema, I'm gonna get already an error because I need to fetch the subfields. So, when you do control space here, you're gonna get the suggestion for this. If I try to do a suggestion for subscribe to podcast, I'm only gonna get type name, and this is because this is this type returns a union type. So when I try to fetch this, I get the type name, but I'm not getting any other field because in unions in GraphQL there is a special syntax to basically say I want to fetch this union. I want to fetch this field for this union, and it's called fragment syntax. So you can do triple dot on specific type. So one of these three types. So for example, if there is the podcast does not exist error, you can do message, and you can do the same for already subscribed, and finally on success we can get the podcast and maybe getting the ID. And this could be, we can also have maybe like subscribers, and this could be useful to kind of get the updated value of the subscribers, which I don't have now. So when I run this, I'm gonna get the type name, which I guess I could ignore, but it could be useful to kind of do a switch in your clients. And in this case, I'm gonna get the proper message. So podcast does not exist. If I try and put the right podcast, I'm gonna get already subscribed to podcast. And if I put the podcast I'm not subscribed, I will get the podcast back. And this is one of the nicest way of doing error handling in GraphQL. So basically, you put the errors into the schema. So basically giving your user a way to identify what's happening in a specific mutation. And when you go and see the docs, you can see that subscribe to podcast has this type. It's a bit verbose, but it's a union type of these three types. Okay. There's one thing that's a bit annoying on this, though, is the fact that we have basically the same selection for these two fields. For these two types. So there is a way to improve this using interfaces, which I think I put it there. Yeah. So as I mentioned, these two types are basically the same. So we can use an interface to basically model like a generic error message, and we can still get the granular type, but we can also make it easier to kind of fetch the same field from this interface. I think it's going to make sense if I show you. So I'm going to update these two type, and I'm going to create a new interface at the top. Okay, so in Strawberry, interfaces are basically the same as types in terms of how you implement them, with the difference that instead of doing strawberry.type, you do strawberry.interface. And then when you want to implement an interface, you just extend from that interface. And now when I go back to my schema, I'm going to see that these two types here are implemented that interface, meaning that I can fetch the field directly from the interface. So if I refresh this, I'm going to go into my schema here. I can see this one implements error, and I don't know how to go back, but this one also implements error. So now instead of doing this double fetch here, I can do on error, and then I can just do this. And this is much nicer, and it gives you a generic way to handle all the errors. And you still have a way to kind of put more information on a specific type. So for example, if you wanted to do this on already subscribed, you wanted to fetch, for example, subscribed on, and you wanted to show, you already subscribed, you subscribe on, I don't know, 1st of March 2023, you can do, you can still pass additional fields, so you can make these errors very, very granular and very, very powerful as well. Cool. That's pretty much it for the errors. Again, do you have any questions? Okay, I'm just gonna keep going. So these two sections are quite basic in the sense that they don't have a lot of information, because this is something I want to work on more in Strawberry to make it easier to make your GraphQL API secure and performant. So the first one is about safety. And again, we already seen some of this. So we already seen that, like, if I'm allowing user to fetch anything, I should put some safeguards into place. Like, I don't want them to fetch everything. And so the first thing, like the most basic thing you can do in GraphQL is to limit the query depth. So for example, if I'm trying to do, let's say that we implemented a list of episodes for a podcast. So we could do, you can fetch a list of podcasts, you can get the episodes for the podcast. But on our episodes, we also have a podcast field, so we could do a query like this, which can be deeply nested, and so that's going to be very draining for your service. It's going to do a lot of SQL calls, it's going to a lot of data, and so one basic way of doing this is to basically say, I'm not going to run any GraphQL query that has more than 7 levels of nesting, and this is pretty straightforward. You just do an extension and implement it like that. I'm just going to show you this. So in this case, I'm going to do 2 because I don't think I have something that's more than 8. But basically, when I try to run a query that's more than 2 levels of nesting, I'm going to get an error. Maybe not this. So I'm trying to fetch a podcast. I'm going to fetch the D. Oh, I think it's, yeah. Wait. I need to check what's, oh, there we go. Should have worked with 2 as well. Okay, I think it counts from downwards. Okay, skips the first level, which makes sense. Yeah, so basically, if I try to run a query that's more than one level of depth, in this case, it's going to throw an error. And this anonymous here is the name of the query. So again, we can see that goes there as well. Again, this works in some cases. It might not work in other cases, so it really depends on what you're doing. There's another powerful thing, which unfortunately we haven't implemented in Strawberry just yet, but it's going to come soon, which is the query complexity calculation. So this is a way to kind of give you a way to calculate if a request is going to, has the potential of fetching too much data. So in this case, I'm saying I want to fetch the first 50 podcasts. And for every podcast, I want to fetch the first 50 episodes. And the way, in this case, you can do some kind of weight calculation. So I'm going to say this field is going to weight 50, and then every field of this is going to be 50 as well. And I'm going to do 50 by 50, and then the result would be 2,500. And so the total complexity would be this multiplication here, because there is going to be, it's fetching 50 episodes for every single podcast, so it would be 50 times 50, and then the podcast of complexity of the podcast here is 50, so the total complexity would be this one plus this one, which is 2,550, and you can basically have some piece of code say, oh, if the complexity is more than 3,000, don't try to run this query at all. I mean, that query might might return only one item, but it has the potential of returning a lot of items. So you can basically skip all the requests being done there. Which is, again, it's a nice way of doing something like that in GraphQL. There is also this is for Node, but there is also this called kind of plugin called GraphQL Armor, which I'm going to implement for Strawberry as well, which gives you all this kind of nice way of limiting what someone can do with your GraphQL API. So the first one is using the costs. I mean, this has a lot of options, but basically it prevents you to do like a query that's more than X amount of cost. But there's also like the aliases. Like I showed you before, like you can do like this. Oh, let me disable that. So you can do this, like you're fetching A and B, and basically you kind of circumventing any limit that your API might have. And so like a nice way of, well, an easy way of preventing something like this is to have a code that says, oh, you can only have maximum 10 aliases in your code. Like this is called an alias. So it's basically it's a way to give another name to a field and also to fetch the same field multiple times. And yeah, so that's pretty straightforward to implement. Probably gonna be done by the end of the sprint this week. This is something we already have, which is the max depth. There's also a way to limit the number of directives, which we haven't seen, but in GraphQL we can have directives, which is a way to change the execution of a field. So in this case, I want to include only if this will be a variable. So if the variable is true, I'm going to include that field. Otherwise, I'm not going to include it. For example, if I do false, this is only going to return B, which is a nice way to have a generic query. But like an issue of directives that you can put a lot of them, and those are going to run code, and like sometimes also the parser might be slow, and so running. In this case, actually, it doesn't run multiple times, which is nice. But there are some parsers that basically, like if you have a lot of directives, are going to slow down a lot, and it's going to lead to DOS attacks. What else? And there's also max token or character limit, which is basically a way to say, oh, if this document is too long, don't run it, which could be useful in some cases. And yeah, this is going to be implemented hopefully soon in Strawberry. There's also one thing here, which is again about safety. When you put a GraphQL API on production, like one of the key suggestions from people in security is like you should hide the introspection. So if what I'm doing here, basically using the information about the API to build the documentation, and the people say hide that because it might give you information about your schema to attackers. There's one additional thing that you could do that. You can hide the introspection. I think we have also an extension for that. But you can still do something like this. Maybe I don't know if this isn't. Yeah, so if you try to fetch a field that's a similar name to another one, you're going to get a nice helpful message that's going to tell you, oh, this is the field that you meant probably. And there are tools like, GraphQL. Yeah, like this one that basically use this feature of GraphQL to find all the schema automatically for you. So like disabling the schema might not be the best option because there's still ways to find out. Again, this is something that you're going to make easier to disable in Strawberry. Like if you're running in dev, you're going to get this nice message. But if you're not running in dev, you're not going to get any suggestion. And again, this is going to come up hopefully soon, rather than later. Do you have any questions about security? Because I think there is a lot of things to talk about, and I'm definitely skip some of them. So just let me know. Okay, the last thing I wanted to show you before doing a recap, maybe, and taking more questions, is the tracing part. So, and this is something that's still quite new in GraphQL. So, I mentioned like GraphQL, every request responds with 200 usually, which makes tracing and monitoring quite difficult. So, so there's tools like Apollo Studio from GraphQL that allow you to, from Apollo. Let me see if there is an example of this. Yeah, so basically there are tools like Apollo Studio that allow you to get the metrics for all the queries. There's quite a few others as well. So you can see all the information, like, for example, if the requests have been requested the most, the operations have been requested the most, the ones that are the slowest, and so on. And all of this is quite nice. The only thing is that you need to use some of these tools which are usually paid, and it's another tool on top of what you already have. But you can also still use tracing, and you can also send this information to like service like Datadog. And in Strawberry, we have implementation for Datadog, Open Tracing, and soon I think Sentry. And they basically work the same way as the other extension. And so basically, every time you run a SQL query, a GraphQL query, this extension is gonna kind of check all the things that you're doing, and it's gonna send it to Datadog, and you can get something like this, which is, I can understand this is not super useful, but you basically can see all the resolver that are being called, how long they take, and so on, which is it's the way that you would do tracing in GraphQL. So basically, it's a nice way to understand how long a field would take. Something that we've done in the past is also to add additional metrics, and for example, using operation name to send information about the operation. So every time there's an operation, you log how much it takes, and then you send it to Datadog, which is something that's pretty straightforward to implement as well. I don't know if I have an example of this. I want to check. I wanted to try Sentry today, but I didn't manage to make it work in time because it's a bit nicer. Actually, I might have Sentry for another project. Hopefully it's Google. No, unfortunately, I don't think we have it here. But you basically will get something like this, and here you, instead of getting like generic ASCII request like this one, you will get one transaction for GraphQL request, which makes it very easy to understand like the slow ones and the ones that you have to optimize. So you can use things like that, this to basically see, oh, this is taking too much time. And yeah, we do have some, like tracing here is not really put it well, but that's basically what you would do for just optimizing the GraphQL queries. And again, you can use tools like Apollo Studio, or there's others which I don't remember the name, which makes it easier to optimize your GraphQL quest. But again, Strawberry supports Datadog and Open Tracing, so you can use those tools to optimize all the requests, so you don't have to use a third-party service. Yeah, and that's, I think I went very fast on this, so I'm just gonna take some time to answer some questions you might have. One additional thing I wanted to mention of this, like we have a very friendly Discord, so there is quite a few people there that usually answer questions, but otherwise I'm also there to answer anything you might want to know. And yeah, the website, we're actually working on a new website, which is going to be released, I'm not going to say soon, but hopefully by the end of this month or next one. And yeah, again, like I'm really passionate about this project, so if you have any questions, like you can reach out to me. on Discord. You can also find me on GitHub. Like if you go to Strawberry, you should be able to find me pretty easily. And there's my email on here. So you can send me an email there or any place where you can reach me. I'm happy to take any questions. And yeah, before doing a quick recap, it might be helpful. Just if you have any questions, just fire away. Happy to answer. Yep.
Have you done any benchmarking against REST framework, like particular in
Yeah, so the question is, have you done any benchmark against REST framework? No. At the moment, we only done benchmarks against other GraphQL implementation in Python, and the performance is the same because all the Python GraphQL APIs are using something called GraphQL Core, which is the core implementation of this library. Like it implements the execution. We are basically like a syntactic sugar on top of this, and so there is some performance issues here, mostly when you return a lot of data. So if you're returning tens of thousands of items, it's going to be a bit slow because what's happening there is it's validating every single item against the GraphQL schema, which is quite annoying. So this is something that we're trying to work on to make it better. There's a project a friend of mine is working on. It's called Rustberry, which is replacing some parts of GraphQL core in Rust. At the moment, it's going to be mostly validation and parsing, and that's going to make things a bit faster. But my goal in future is to get as fast, if not faster, than Django REST framework. And some ideas there, it's just I don't have enough time, unfortunately.
So what do you think the drawbacks of GraphQL if you're considering going for REST?
Yeah, so drawbacks of GraphQL. So that's a very good question. I mean, there's different sides of saying that. Definitely one thing is like if you never use GraphQL, it's quite foreign. So like understanding all these things like about, not even just performance, but also like security and monitoring. Those things take a bit more time, because especially you have to use tools and things like that. And yeah, it also depends what you're building. So if you wanna, like my suggestion, if you wanna try GraphQL in your work or for a side project, try to do something small, but also start from the front end. Like try to implement, maybe do a small API, but try to implement as soon as possible on the client, because where you get the benefits, it's on the client, because you have this nice nice way of fetching data. Maybe I can show you an example of this. I don't know if you're familiar with React, but in let's see if there's an example. In React, you can use tools like Apollo Client, where you basically define a query like this. So this is a query that we've been working on before, and you can use a hook, which is basically returning you loading errors and data. It's like this line is basically giving all the GraphQL things, which is very nice and very easy to use. So you will get a lot of benefits from just trying this on the front end. That's definitely my suggestion. But in terms of trade-offs, like one thing that GraphQL is not really good at is public API. So if you're doing an API that's going to be used by third parties, like for example, for example, the GitHub API is used by other developers that are not from GitHub. Building an API, public API in GraphQL is quite difficult, because again, you should make an API that's more focused on the use case. And when you're building a public API, you don't know what the use case is going to be. So people are going to implement random things and going to make things that don't make sense in the way you shape your GraphQL schema. So public API is definitely, it's doable, but it's not simple. And on top of that, service-to-service communication, I don't think GraphQL is the right place for doing that, because if you have microservices, you want to communicate between them, I will use gRPC because it's faster and also it's made for that use case. Like GraphQL, the fact that you have to specify the query is powerful for the client, but when you're server to server, I don't know if you get the benefits of being able to specify the fields that you want. Maybe you can reuse the API, but again, the API should be made on the use case, and again, use case should be done for like a client using API. So.
Have you ever encountered situations where someone is implementing an app that's half GraphQL or 35% GraphQL, the rest of it is REST?
Yeah. So the question is if I ever encounter places where like half of the API is REST and half of the API is GraphQL. Let me try to think. We had something like that, but not exactly that. So one thing I've seen in the past is like people creating, which I definitely wouldn't recommend, is creating kind of GraphQL resolvers on your front end. So you will use GraphQL on your front end, but also on the front end you would call REST. So you would create like an interface on top of REST inside your front end, which is okay, but you're still doing a lot of requests there. So like something that's quite common is to do a tiny GraphQL API, start with that, prove it that works, and then slowly migrate things from REST to GraphQL. And you can still wrap your REST API with the GraphQL API. So you can do, like for example, the podcast field could be backed by REST API, and then if you want to move it to skip REST, you could do that as well. But like using GraphQL to wrap REST API is quite common. It's something I was doing in my previous work. Yeah. Do you have any other question? Cool. Yeah, so I guess the recap is basically we've seen how to kind of set up a GraphQL API with Strawberry. We've been using Django, but Django, again, is something that's just an implementation detail. And I can show this again. We had these models here, but we were not looking at them directly. Like all the code that was doing the data fetching was kind of hidden by this kind of service layer, I call it, which is inspired by domain-driven design. It's basically like a facade on top of your database. It makes it easier to work with these kind of things, and you don't have to think about all the implementation of your database. And it also makes it easier to reuse this. For example, if you need to create a REST API for some specific use case, or if you need to create a CLI, from this you can reuse this service layer, and so you don't have anything that's specific to data fetching inside GraphQL. And we use async for data loaders, which is a way to optimize the requests. So to batch multiple requests into one. And in Django, like there's some issues at the moment with running async requests, database call inside async context. So I guess it's worth showing you since we have time. Like there's this function called sync to async, which converts a sync function into an async function. So you can do a wait, and it basically prevents those issues with Django. Basically what happens, like things run into a thread, which it's a thread where the database also runs. The database connection also runs. I'm not clear on the details why this is an issue, but this is what's happening. There's also, let me see. In Django, you can also do a filter. I'm not sure this. Oh, okay. No, a filter is not there yet, but there's also things like a get, which are the like asynchronous variants of get and a delete and so on. This underdo are still doing the sync to async at the moment because the database layer in Django is not async, but hopefully that's going to change in future. And again, it's also one additional reason why to create like a wrapper class that makes wrapper layer that makes it easier to work with database. And I've done this for everything, and you can see sync to async is done on list in most cases because like Django is lazy. So up until you don't use, for example, query set, it's not gonna do the actual query to the database. So sync to async is on list, which is a bit confusing. Okay. What else? Yeah, we've seen how to do pagination, so you can do basic pagination using, pages. The suggestion is to think about the use case. If you need to have page pagination, you can use something like this, but make sure that you use a kind of nested wrapper type, so you can do as next page, you can give you more information about the pagination. And on top of that, make sure that you have some basic validation so you don't allow users to fetch too much data. We also seen how to do some of those things with the just safety features, and hopefully this is gonna be easier in the next version of Strawberry, hopefully from next week. So you can kind of prevent users to do too many fetches in one single GraphQL query. And we also seen the cursor pagination, which is useful for if you're working with a GraphQL API that's already existing, it's probably going to use the relay specification, which is very common. And again, this is something that looks like this. So you have a field that returns a list of edges, and every edge is a node, and every edge is also a cursor, which is how you can paginate and get things from there. And you can also, again, like the reason why you have edges is that you can add additional metadata here. So for example, like the user, the friends can have a relation together, and it would only make sense in this context. It wouldn't make sense to the single friend to have a relation connection. Yeah, the relay it's a bit verbose, but it's quite powerful, and we've seen the generic types. We've seen how this makes it very easy to reuse types in Python for creating multiple GraphQL types. Then we've seen like a couple of ways of improving the optimization. Improving the performance of the application by introspecting the query, which is something I don't really recommend because it's tying your database, your GraphQL query too much to your database. So I would definitely recommend you to use data loaders when possible, and for data loaders you have to use async code. What else? We've seen authentication. We've seen like a basic way of doing authentication using cookies. Again, you can use anything that you want, but again, I personally always use cookie-based authentication. It's just so much easier to use, and I think you can also easily use them in native applications. And then, yeah, we've seen mutations. We've seen how to create mutations, which are basically the same thing as query, with some additional changes on how the execution works. What else? Yeah, we've seen the permissions. Hopefully, this is going to be much more powerful in future, but it's already a good way to start. And we've seen how to handle the errors. So I think this is one of the like most common patterns if you search for errors, like just using the union types to make sure that you basically tell your clients how to handle multiple responses. And yeah, I think that's pretty much it. Again, like keep an eye on this page. I'm gonna update it to add more things, and also to remove some of the like code that's not gonna be needed in future. Like for example, for relay. Again, hopefully this is gonna be all implemented. Or most of this is gonna be implemented by Strawberry itself, so you don't have to do all of this. And same thing goes for the safety part. There's gonna be a lot more options here, and I think we're also gonna have like a way to kind of set the same defaults. Maybe even, by default, like when you install Strawberry and you try to run queries, like there is a lot of these things enabled by default, so you don't have to worry too. Yep.
Kind of going back to a little bit back to the beginning, when you were importing those podcast feeds, how does GraphQL know what the option, what the parameters are that it can use to get data out of those feeds?
So the way we, so if you go back to the CLI, I haven't shown you the CLI actually. So this is just it's not really part of the workshop, but basically I'm fetching RSS feeds for the podcast, and I'm putting them into the database. And models. So these are all the options, all the things are available in the database. So there is the title, subtitle, description, and so on. And there's also the episodes. And when I go back to my podcast query, when I'm fetching a single podcast, so I'm fetching that by ID on the database, and here I'm getting a Django model, which has all the title, as the title, the ID, description, and so on. And then when I'm doing the conversion, I'm creating a GraphQL type, which this is where you're telling GraphQL what fields you can fetch.
But you have to know beforehand what you're getting, so you can define the model of what it is, right? This is my feed, and I know I'm going to get these different items, and I put them into your model, so you have to query them, right?
Yes. Yeah. I mean, the way I've done this is a bit backwards, or maybe not too much. Like I already have a data source to work with. But for example, if you're working with your own business logic, with your data, you know what data you have, and you know how to shape that for GraphQL. Because again, it should be shaped based on the kind of use case that you have. So for example, in this case, I mean, this is, again, it's a very simple use case, but I didn't have a hosted by field here. If I wanted, I can add it, but in my application, I didn't need to show that, so it's not present in the GraphQL API. Again, I think, I haven't mentioned this, but in GraphQL, like something that's pretty cool, like adding new fields is very easy. So you can do ABC and string, and that's done. You don't have to do anything else other than putting here when you fetch it. I can do ABC. I can also put a default, so you don't have to do anything. And like this is something that, for example, in REST might be a bit annoying, because like once you add the field to REST endpoint, it's going to be returned to all the clients using that endpoint. In GraphQL, this field is only going to be returned if someone requests it, which is very powerful. And so my recommendation is only add the fields that you need at the moment, and always add them in future if you need more. Because like once you have a field in your schema, like remove it is a bit non-trivial, because you need to make sure that it's not being used. Which there are some, like Apollo Studio tells you like how many times a field is being used, for example, last week. And you can check that as well. But again, it's an operation that requires some step. And you can also deprecate fields if you need to. So for example, if you don't want to, if you want to tell user to not use the description field, you can deprecate it. And so like they get a warning inside the IDE. It's still going to work, but they know that's going to be deleted at some point. That's, again, pretty much it. Again, if you have any question, you can go to Survey.rocks. There is all the links there. I'm going to be around for us today and all the rest of the conference. I'm organizing the sprints, which I forgot if they're on Saturday or Sunday. But basically, I'm going to work on like all the things that are missing for the safety, and hopefully maybe improving the workshop as well with more information. So make sure you take an eye on this. And that's pretty much everything. Thank you.